back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And today, we're going to talk about what's out there. In fact, the book's title is Out There, a scientific guide to alien life, antimatter, and human space travel for the cosmically curious. With us today is Dr. Michael Wall, senior writer for Space.com. He's written for Scientific American and a number of other publications, and he got his PhD in biology from the University of Sydney in Australia. So today we're talking about what's out there. Late at night, have you ever looked at the night sky and wondered, wow, the universe is so huge, there's got to be alien life someplace in the universe? If so, how come they haven't reached us? And for that matter, one day will we reach for the stars? And so, to talk about these things is Dr. Michael Wall, author of the book, Out There. Today we're going to be talking about Mars. We're going to be talking about spaceships. We're going to be talking about alien life in outer space. And our special guest, once again, today is Dr. Michael Wall, senior writer at Space.com. Well, the first question that we always ask our guests is, when you were a child, a youth, what stimulated you? What got you going in the direction of science?
Yeah, well, I mean, I grew up like in Arizona, and there was pretty pristine desert right around my family's house. So like I have all these memories of sort of going outside, going on a walk through the desert, and seeing like lizards scurrying around, and sort of chasing them down, and like keeping them in like little makeshift terrariums and just watching them. And that's probably what got me really going. You know, I was a biologist before I became a writer. And that's probably what started it, just being able to go outside and kind of chase animals around and actually look at them and look at their behavior up close.
Okay, well, once again, making the news on Space.com, in fact, is Elon Musk, the CEO of Space.com, SpaceX. And he has come out with more details of his proposal to colonize Mars. He's envisioning 1,000 ships, each ship carrying a few hundred colonists, spread over a 20-year time frame to begin the colonization of Mars. Well, very ambitious. First of all, what are your thoughts? And if you can explain what the pros and cons are about a mission that grandiose, 1,000 ships to go to Mars over a 20-year period. What are your thoughts?
Yeah, I mean, it is very ambitious. I mean, Elon Musk is certainly nothing if not ambitious. He definitely dreams big and tries to make that a reality. So I'm not surprised that he's dreaming that big. It is kind of jarring to hear a vision that grand, though, when we haven't even put anybody on Mars, to hear plans of like thousands of ships going back and forth. And he eventually wants to help set up like a 1 million-person city. And, I mean, I don't know that that's going to happen within the next 20 years or the next 50 years. I definitely do think we're going to get there. I mean, boots are going to go down on Mars within the next 10 or 15 years, I think. We'll just see how sort of difficult it's going to be for humanity to set up a kind of self-sustaining outpost there. I think it's going to be a little more difficult than some of the exploration advocates think. I think there will be some fits and starts as we figure out how to live in another world and how to actually make that happen without constant resupply from Earth. And I think it'll be a little more difficult than people think, but we are on that track, and it's because of people like Elon.
Okay, well, the dinosaurs did not have a space program, and that's why the dinosaurs aren't here today to talk about the question. We do have a space program, and according to the laws of physics, it's only a matter of time before we have to leave the Earth. I mean, in 5 billion years, we have to leave the Earth because the sun will gobble up the Earth. On a scale of millions of years, we have to worry about asteroid impacts. And so could you explain what is the philosophy of Elon Musk to be so ambitious to create this concept of hundreds of ships going to colonize Mars? What drives the guy?
Yeah, well, his kind of overarching ambition and why he started SpaceX is basically to make humanity not just confined to one planet and therefore very susceptible to extinction. And these things you were talking about are going to happen at some point. In about like 700 million years, actually, that's like our kind of drop dead date, because at that point, like, the sun will have become hot enough. It's like gradually getting hotter and hotter to boil away the oceans, and we're going to have a runaway greenhouse effect here on Earth, and we'll end up like looking a lot like Venus. So we've definitely got to get off Earth by that point, and that's a lot of time. But there could be a catastrophic asteroid impact before then. We are currently doing a lot of bad things to the planet that could do us in way before then. You know, climate change is proceeding very rapidly. We're doing a lot of bad things to the planet, and so it's good to have a safety valve. It's good to have another world where we can kind of set up the civilization, preserve human culture, human knowledge, get the human DNA. That's the idea, that we're not just confined to one world, so that if something bad happens here, we don't go down with the ship. And that's sort of his overarching vision. And it's also, it's not just that vision. He also thinks it's important for us to explore, just because we're an exploratory species, and it's sort of good for the human mind and the human spirit to have exciting things to look forward to. That's certainly part of it, but that's kind of the secondary ambition.
Well, let's talk about the economics of this grandiose scheme. First of all, some people say, why not mine the asteroid belt to pay for it? Because the asteroid belt has plenty of platinum-based chemicals, and Google billionaires are also jumping into the game. It's just not Elon Musk. And they want to begin the process of perhaps paying for all this by mining the asteroid belt. What are your thoughts?
Yeah, I mean, I think that is part of the long-term vision is getting these precious metals off of asteroids where they're there in huge abundance. But that's a little farther down the road. I don't think we're going to be at the kind of, at the metal mining stage with off-Earth mining in time for us to do these grand Mars plans that Elon Musk is sort of talking about. I mean, mining metals off of asteroids in like any conceivable or any large enough quantities to make a difference is still decades away. So to fund the Mars missions that we're talking about, that's too far off in the future. And but you've hit on like the big problem is the stuff is all going to be very expensive, and how we're going to pay for it. I mean, Elon Musk has a lot of money, but he doesn't have enough to fund every single launch of these starships out of his own pocket, So we're going to have to find ways for people to pour money into this. Maybe there'll be, maybe we will find like life on Mars, and we'll be able to sort of look into like the genetic code of that life and make all sorts of biomedical discoveries. Maybe there will be some novel chemical that a Mars microbe produces that like we can use in the biomedical industry, and maybe that will be the thing that kind of pays for Mars colonization. Is that those sorts of things are what people are thinking about. But I don't know what it's going to be to kind of fund our giant leap off of Earth. People are still trying to figure that out.
Okay, well, let's take a short commercial break. Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Dr. Michael Wall, author of the book Out There, a scientific guide to alien life, antimatter, and human space travel for the cosmically curious. Well, Elon Musk, the billionaire behind SpaceX, also made waves recently when he said that the key to the colonization of Mars could be melting the ice caps of Mars with hydrogen warheads. So what are your thoughts about the ice caps of Mars? Could they melt to create a Garden of Eden on Mars? And is detonating hydrogen bombs over them the best way to do it?
Yeah, it's another big ambitious project. I mean, I don't know if he's 100% serious about that, but like the idea is basically Mars is very cold and extremely dry today, but it does have a lot of ice locked up in the polar caps. So the idea is if you detonate that ice and kind of transition all of that ice into water vapor, and also carbon dioxide vapor, because there's a lot of CO2 there too. Both of those are like very potent greenhouse gases, and they can thicken up the atmosphere of Mars and trap more heat and maybe transform it into a warmer world that could support liquid water on the surface and so on. and there are people who have thought about this seriously. You know, lots of different ways to sort of do it. We could, for instance, like send spaceships there to kind of set up big orbiting mirrors that will focus sunlight down onto the poles and kind of melt the ice the slow, kind of older-fashioned way. Or like we could sprinkle dark flecks of something on the ice caps so they absorb more heat and they melt that way. But yeah, I mean, in typical Elon fashion, dreaming big, he's like, well, let's just blow them up. That'll do the job faster. There are a lot of studies about this. People have come out and said, like we don't think that there's enough CO2 and enough water vapor in the ice caps to actually make a difference. And yeah, so it's pretty unclear if that would even work. People debate this, and I don't think that we really know how to do it. And then there's the ethical side of things. Mars might have had life in the ancient past, but might still have life today. And do we have the sort of right to just go there and turn it into like a world suitable to us and to Earth-like life just because we want to go there? That's a big debate too. Is this terraforming idea even ethical? Do we have the sort of right to do it, even if we can do it, which is an open question. Both of those are big debates that are going on now in the exploration community. People are trying to figure out what the best way to sort of do this is.
Well, some people think that we are already terraforming a planet. The planet Earth is being terraformed for good or bad. And the key to the terraforming of the Earth would be if you hit a tipping point, a point at which it takes off all by itself, and then we're in deep trouble. But why not do that on Mars? We had Dr. Robert Zubrin on the air, and he said that if you could raise the temperature of Mars just by a few degrees, maybe 6 degrees or so, a runaway greenhouse effect would come in, and Mars would basically terraform itself. So what are your thoughts about those people who think that a runaway greenhouse effect could be the key to creating a Garden of Eden on Mars?
Yeah, and I mean that's certainly a possibility. Dr. Zubrin is one of the chief advocates for the human exploration of Mars, and he's a very smart man, and he has very interesting ideas about how to do that. I mean, there are people who do disagrui with him that it's advisable, or that we should do it, or that it would be quite as easy as he says it would. And I mean, I have a lot of respect for him and his ideas. I'm just saying that the science is probably not all that subtle. That's my reading of it. And people also make this is an important part of the argument too about the ethical side of things. I mean, Mars and our planet have been sharing rocks for 4.5 billion years, basically. Asteroids hit the Earth. If it's a powerful enough impact, some of those rocks make it out to Mars. The asteroids hit Mars. It's a powerful enough impact, some of those rocks make it to Earth. So some of the people on the terraforming side of things would argue, we wouldn't be contaminating Mars with Earth life all that badly, because we've already been trading rocks so much that if there was life on Mars, it's gotten here, and some Earth life has definitely already gotten out there. So we don't need to worry so much about the ethics of it. But yeah, I mean, terraforming an entire planet is a little different than just having a few microbes kind of landing on a planet every 10 million years or so. So yeah, it's an area where there's a lot of debate and people with strong feelings on both sides.
And speaking about life, most people think that, well, maybe no life on Mars, but what about the moons of Jupiter and Saturn? They have liquid water oceans underneath the ice cover. So if that's true, then maybe all the Jupiter-sized planets that we see have moons that could harbor life. So what are your thoughts about the idea that life in outer space could be aquatic on the moons of gas giants?
Yeah, that's really exciting. That's one of the things that we've just started to sort of realize just in the past 10 years or so about these. I mean, gas giant planets. I mean, if our own solar system is any guide, it's very common for them to have icy moons, ice on their surface, like an ice shell, with a big liquid water ocean underneath that ice shell. Those might be the most common habitable worlds in the galaxy, because we have multiple examples of those, and that's really exciting. We didn't know that just 15 years ago or so that they were so common. And I personally think that there probably are a lot of those moons out out in the galaxy. I mean, just sort of based on our own solar system as an example. That's exciting in some ways. It's kind of depressing in another way, in that it's hard to kind of look for life in those oceans. You know, Europa, Jupiter's moon, which is probably one of the best bets to harbor life, it's got an ice shell that might be 20 miles thick. So it's going to be really hard. I mean, you have to drill down into like the ice shell at least a little bit to find like maybe like degraded DNA from the ocean if it worked its way up there, maybe through plumes or through vents. Yeah, it's really exciting to sort of think about these worlds, but it's challenging to think about how you would explore them and how you would find any life that might be swimming around there in the dark, frigid depths, like under this ice shell.
And also, when we think about aliens in outer space, we think that they're going to look just like us. However, if life actually starts in an aquatic environment, maybe they could be more like a fish or an octopus. But if that's true, perhaps they won't have any electronics, because electronics would be short-circuited by water. So maybe even if there are life forms underneath the ice cover of Europa, maybe they're not spacefaring because they have no electronics. But what are your thoughts?
Yeah, I think that's a very good point, and that's something that we have to keep in mind. You know, people wonder, like, yeah, I mean, are we alone in the universe? If there is life out there, why haven't we gotten in touch with it? And you know, we can talk about this more. There are lots of possible answers to that question, but one possible answer is what like you just said. If most life out in the galaxy is some sort of aquatic life form, and a lot of them are trapped under these ice shells where it's dark all the time and they can't have electronics. Like, I mean, yeah, they might not even, they might have never seen any kind of sky. They might be blind. Like, they might not know that there's a whole galaxy out there with other stars. So even if they could build a rocket ship, maybe they wouldn't even know where it could go. So yeah, this is just like, I mean, we have to realize that there could be all sorts of different types of life forms out there. You know, we might be an outlier in that we live on land and we walk upright and we have electronics. I mean, maybe most of the life in the galaxy is aquatic. Maybe it's only microbial, and that's why we haven't communicated with it, because it hasn't been beaming radio signals out into space for the last 100 years when we've been sort of paying attention to that stuff.
Okay, well, then the next question is, asked by Enrico Fermi years ago, is where are they? I mean, if there are so many intelligent life forms teeming in the galaxy, and they're advanced, much more advanced than us, then why don't they visit us? So what are your thoughts about that question?
Yeah, that's a $64,000 question, you know, and that's like, mystery has only deepened over the past 10 or 15 years as we've learned how common habitable planets are. I mean, we've just learned basically that 25% of all of the 200 billion stars in the Milky Way likely have a relatively Earth-like planet. I mean, one that's about the right size to be rocky and about the right distance from its host star to have liquid water on its surface. So you're talking about 50 billion potentially Earth-like planets. And so, yeah, it's like, why haven't we found any evidence of life? Why haven't we seen spaceships in our sky with that we've been able to confirm, because a lot of people say that we already have. Why have we not intercepted some kind of communication?
Welcome back to Science Fantastic with Professor Michio Kaku. Well, once again, with us today is Dr. Michael Wall, author of the book Out There, talking about alien life in outer space. Well, where we last left off, we were talking about the possibility of alien life out there, but how come they don't visit us? I mean, after all, if they're that advanced, perhaps millions of years ahead of us, that's nothing compared to the age of the universe, then they should be able to reach us and say hi, land on the White House lawn, and give us the benefit of their technology. At least that's how the Hollywood movies have it. But, well, what are your thoughts on this question?
Yeah, I mean, I think there are probably a lot of things working against that scenario, and they're all working in the same direction, making it pretty unlikely. I mean, first of all, we've only been in a technological civilization for about a century, so there was a whole stretch of about 4.5 billion years when Earth life had no signs of any kind of technological intelligence. So, I mean, it seems likely that that there's a long stretch of sort of like microbial only life on a planet. That's what happened here on Earth. We were microbe only for about 3 billion years, and then we finally hit some tipping point, crossed some threshold where sort of complex life evolved, and then it took another really long time before intelligent life evolved. I mean, talk about technologically intelligent life. There are all sorts of different kinds of intelligence, but the kind of life that can beam radio signals out into space, build spaceships, that's only like 100 years old, 50 years old when we talk about spaceships. And so, I would guess that it's pretty uncommon for a planet to develop technologically intelligent life, just based on our example. And then you talk about the immense distances of space, just how far away. If there are only a few of these things kind of fleck throughout the entire galaxy here and there, they're probably thousands and thousands of light years away, and they would have to coincide with our rise in timing too. Like they would have to have reached the same point we are at about the same time we have. And when you think that the galaxy is almost 14 billion years old, those are pretty long odds for everything to kind of shake out. And then with those distances, you need a lot of energy to be able to traverse those distances, which costs resources. And so, not only would an alien civilization have to know about us in the short time frame that we have been knowable, they would have to be very motivated to get over here and have the means to do it and the energy to do it and the kind of rationale for doing it. So, all those things have to line up just right, and have to have lined up just right in the last 100 years for us. And so it's not all that surprising that it really hasn't happened yet.
Okay, well, when you watch a Hollywood movie, many people are waiting for the money shot when they show the aliens from outer space. I saw the movie Contact, which of course was written originally by Carl Sagan, and the ending I thought was rather disappointing. After waiting an hour and a half to see what the aliens look like, you don't see the aliens at all, because they can be anything they want to be. But your book actually tries to address that question. What are the aliens going to look like?
Yeah, and it's a disappointing answer, but it's sort of like we have no idea, right? We want to impose all of these thoughts on what alien life could look like, because we like things to be orderly in our brains, and we want things to be familiar to us. And yet with sci-fi, sci-fi movies, sci-fi shows usually have aliens as bipeds. They kind of look like us, but they're a little weird. The whole Star Trek thing where they have green skin or they have bumpy heads, and that's because costumes are a lot easier to make for a person who walks on two legs, but also because we just identify.
Okay, let's take a short commercial break, and after the break, we're going to talk about flying saucers. What are these things that people have recorded from the United States Navy and Air Force? Welcome back to Science Fantastic with Professor Michio Kaku. Once again, our special guest today is Dr. Michael Wall, senior writer for Space.com, and the book is called Out There, and we are talking about, alien life in outer space, and, the fact that in the Hollywood movies, maybe they're too conservative. Alien life in outer space, can't they be cybernetic, or can't they be augmented using genetic manipulation? If they're that advanced, they can pretty much look like anything they want to look like. But, what are your thoughts?
Yeah. I think once they reach a certain point of sort of technological sophistication, I think it's very likely that advanced life will be digital, at least in some respect. We're already moving in that direction when you talk about all these implants people are getting. If you've been partially paralyzed, scientists have already developed gear where they can implant it into your brain to help you move like a paralyzed limb, just using brain waves and kind of technological implants. And so we're already on that path to becoming cyborgs. It sounds kind of silly and futuristic, but that's already what we're doing. And so if you extrapolate that out a million years, if we continue going down this path, we will have sort of melded with machines in a very real way, and we might not even need physical bodies. And so, I think that's probably what most intelligent life is actually like. I think it's intelligent machines that have figured out they don't need bodies anymore. And so that might be very hard to actually recognize. And then if you go to the other end of the spectrum, if they're like microbes, and if they don't use DNA or maybe they're not even kind of carbon-based, then they'd be very hard for us to find with current technology, and very, very difficult for us to envision. yeah, it's just like we just have to keep a very open mind, I would think, is the take-home message.
Okay, well, we get some calls saying, Professor, you're all wrong. You're all wrong. The aliens are already here. They're not there. They're here in terms of flying saucers. So what are your thoughts about the recent videos from the United States Navy going back years showing that, yes, Navy pilots seem to encounter these objects traveling at hypersonic speeds, outracing all our weapons, and being able to harness a technology that seems to be beyond reach? What are your thoughts?
Yeah, I think those are very, very interesting. And, I mean, first of all, I think it's good that people are coming forward with these sightings and not feeling ridiculed anymore like they used to. You know, I mean, military culture used to be much more closed-minded about this. Like, you don't want to say that you saw something weird because, like, you'd be made fun of. But, yeah, I mean, like, I think it's like a very positive step that we're actually taking these sightings seriously and trying to figure them out. That being said, I don't jump to the conclusion that they are alien spacecraft just because that, to me, is a very high bar to clear. I don't know what they are, and I'm not saying that if these people think that they're alien craft, that they're crazy or they're stupid. I just think that it's more likely that it's that there's some earthly explanation that we haven't figured out yet, just because that's the most likely explanation, like in my mind. I mean, maybe it's like a sensor issue with the new gear on these Navy jets that they were talking about. I mean, maybe there's like a software glitch. Like, those are all possibilities. But I keep an open mind and think maybe it's something more. You know, we just don't know, and we just can't discount things out of hand just because they like might be unlikely or seem improbable.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Our special guest today is Dr. Michael Wall, senior writer for Space.com. He has a new book called Out There. Well, Vladimir Putin shocked the world last year by announcing that the Russians have a new weapon, a hypersonic glide vehicle that could travel between Mach 5 and Mach 20, which is the range at which these Navy pilots seem to see something flying in outer space. Plus they maneuver. In fact, that's the whole point. The whole point is that these objects can outmaneuver a Star Wars missile shield. The Chinese have now admitted that, yes, they too are working on hypersonic glide vehicles. The United States actually canceled its hypersonic glide vehicle program 2 years ago, but because of the recent announcement by Vladimir Putin, has reignited that whole controversy. So what are your thoughts about the fact that just like the stealth bomber set off many of the UFO sightings of the 1980s and 90s, that maybe, just maybe, hypersonic drone glide vehicles could be being tested and people are picking them up. In fact, pilots are picking them up. But what are your thoughts?
Yeah. I mean, I would say, I think that's one of the most likely explanations, because where these sightings occurred, you know, close to the coast, but actually not over land, you know, that's where you would expect some of these drones to be tested if they're doing like a reconnaissance mission. You know, you would expect that they would not go over U.S. airspace, go over land where they'd be much easier to detect. And we've heard people say, you know, I mean, people who used to be involved in like U.S. military stealth vehicle development, that they're usually about 10 or 15 years ahead of what they announce to the public. So there's probably a lot of technology that's being developed that's very advanced that we don't know about. So yeah, that's one of those explanations that seems to be a little more likely than an alien spacecraft. But yeah, like we just don't know at the moment.
Okay, well, moving on, in your book, you also talk about starships. Now, of course, chemical rockets would take forever to reach Alpha Centauri, 70,000 years for a Saturn rocket to reach the nearest star. So we have to have some other ways of going at light speed or even beyond light speed. So what are your thoughts? Because in your book, you talk about time travel, you talk about wormholes. Talk to us about what happens when the laws of physics as we know them begin to break down, and perhaps a new law of physics has to come into play.
Yeah, we are exploring new ways to build propulsion systems, right? I mean, if we want to actually get out among the stars, we aren't going to be able to use chemical rockets. way too slow. So there are all sorts of technology development programs going on now that are investigating that. I mean, one of the ones that's promising is called laser sailing. If you have a powerful enough Earth-based laser, it can blast a little probe up to about 10%, 20% speed of light, and maybe get to the nearest stars in the next half century or so. And there's a group working on that right now, Breakthrough Starshot. They actually want to do this and launch these tiny little probes out to Proxima Centauri, Alpha Centauri system, to do reconnaissance of these systems. Those aren't going to be able to propel a crewed spaceship, with people inside. Those will only do these tiny little, very, very lightweight spacecraft. And so if you want to send people, then you've got to do something different entirely. We don't know how to do that yet. We don't even know what the best strategy is. So people are investigating different strategies. I mean, antimatter matter is probably like the most promising, I guess, or it's got the most bang for the buck. I mean, people might be familiar with that from Star Trek, the antimatter engines, because when antimatter it actually meets up with matter, they annihilate with 100% efficiency. It's just pure energy. So if you can harness that, you're in business. But harnessing it's tough, and there's just not enough antimatter out there for that to be feasible at the moment. We don't know how to make it. I mean, in big enough quantities to use it, and so we don't know what the right strategy is. But there are people that are investigating different strategies too. I mean, nuclear fusion rockets might be good. We're sort of investigating those. So kind of most of the people that you talk to are like, well, we should investigate all these technologies. All of them are at the early enough stage that we don't know which one's going to pan out. So we need to investigate all of them to kind of see which are the most promising.
Okay, well, let's take now another leap forward. People who talk about these things are not satisfied with sublight speed rockets. They want to go faster than the speed of light. They want to use wormholes and different kinds of technologies. So what are your thoughts, given the fact that we are now leaving the realm of science and going into science fiction? But what are your thoughts about, wormholes? You've interviewed a lot of these people. What are your thoughts?
Yeah, and that's another thing where people are a little bit, I mean, nobody agrees, or people don't all agree about this. There's some people who say wormholes are a dead end, even if they exist in nature, which we're not sure that they do. We know that they can exist. We don't know if they do exist, and if they do exist, people have done the math where to actually make them big enough to support a spacecraft with people inside to allow them to pass through and to stay open long enough for those people to pass through. You would need a lot of negative energy, which does actually exist, we think, but we don't know how to harness it. We don't know how to kind of thread it into a wormhole to keep it open. It would take just so much of the stuff that it's inconceivable that we can do that anytime soon. But there are others who are buoyed by that prospect and well, it's possible and it's in the math, so we can do it, and we should work on figuring out how to do it. And there are others who just think it's so impractical that it would be a waste of time to kind of go into that in detail. So I mean, I don't know. There are other things a whole faster than light speed travel, warp drive. There are people working on doing warp drives where you basically try to bend space so much that it creates a little wave of space-time that pushes you forward, and you end up going faster than the speed of light. And there are people who think that that's actually possible, and others think it's a waste of time. So we're still in this very early stage in the physics community where people are trying to figure out whether this stuff could actually happen or if it's just theoretically possible. I mean, you would probably know a lot about that more than I do, about whether it's theoretically possible and physically possible. We're just trying to figure that out.
Well, the problem, if you ask any physicist, is the fact that Einstein's equations and even the quantum theory begin to break down what is called the Planck energy, the energy at which space becomes unstable, which is about 10 to the 19 billion electron volts. That's a quadrillion times more than the Large Hadron Collider outside Geneva, Switzerland. So in some sense, we need a new law of physics. A law of physics beyond the Planck energy. And if alien civilizations are out there, then perhaps they could exceed the Planck energy. I mean, a civilization millions of years ahead of us, you cannot discount the fact that they may be able to access the Planck energy, the energy at which space and time become unstable. Well, unfortunately, we have run out of time. Once again, the book is called Out There, A Scientific Guide to Alien Life, Antimatter, and Human Space Travel by Michael Wall, Ph.D., Senior Writer for Space.com. So once again, join us every week on Science Fantastic.